Good afternoon, everyone. Welcome back to Tech Talk Tuesday here at Treadwell. If you're joining us for the first time, welcome. And if you've joined before, welcome back. We hold these sessions every second Tuesday at this time, 1:30 New South Wales, Queensland, Victoria time. And we take about 15 minutes to run through a quick discussion on something related to FRP or design standards or something of that nature. Before we kick off, obviously what we discuss is general advice, not site-specific. If you'd like to have a site-specific discussion, please reach out. I have contact details at the end. And secondly, I've got the Q&A window open now, so if you have a question during the presentation, you're welcome to put it in as it comes up, and we can try and answer it during the presentation if we can, rather than wait to the end, or you're welcome to wait to the end. We'll stay online for a bit to do a bit of Q&A at the end of the presentation. So today we're having a look at FRP best practices. So we're going to talk about cutting, drilling, bolted connections, those sort of things. So we'll get straight into it. While we're looking at this, these are best practices around cutting, drilling, bolting, etc. And they're best practice because they're the procedures that will give you the best possible lifespan out of your FRP product. So obviously, if you're putting in FRP onto your project, you're looking for a durable and low maintenance product. These procedures will help you to achieve best possible lifespan out of the product and the best possible results as far as fabrication and so on. So we'll start off with cutting. We often get questions around how to cut FRP. The best way to cut FRP is, and this is more site specific or on site cutting. Best way to cut FRP is using a power saw, whether it be a circular saw or an angle grinder or a jigsaw, reciprocating saw with a diamond blade. Why a diamond blade? The diamond blade gives us the best possible result, the best quality of cut, without putting excessive heat into the product. So other options you might consider, you could use a timber blade or an aluminium blade. The challenge with, or the limitation with that, is that the glass reinforcement in the FRP product will take the edge off the teeth very quickly, and that blade will become blunt quite quickly. You'll get maybe 5 or 6 cuts out of it, which is obviously not a good result. A friction cutting disc, like a grinding or cutting wheel on metal, typically put too much heat into the product and will tend to soften it as it cuts, and that can char the edge or leave it looking unsightly. So that's why we recommend the best possible cutting results on site or easily achievable is a diamond blade. You're welcome to cut it wet. That's a good option for dust control or having dust extraction. In the factory, we use both some CNCs with diamond tooling and also a 90,000 PSI water jet. So here at Treadwell, we do offer that option to pre-cut your products for you if that's your preferred option. However, we understand that things need to be done on site. We also have and make available for purchase diamond blades and also drill bits, which we'll look at shortly, that we've found to be the best items for cutting and drilling FRP. So in summary, diamond blade, ideally a continuous rim blade, so like a tile blade, rather than a segmented concrete blade. The reason for that is the segmented blade tends to leave the product just looking a bit unsightly, not the smooth finish that we get with a continuous rim blade. So in summary, continuous rim diamond blade for a circular saw or a grinder, or diamond blades for jigsaws and recipro saws. We have those available for purchase as well. Welcome to cut wet, provided obviously that the machine you're using is suitable for that. We don't want anyone getting electric shocks from using a machine that's not designed to use with water. But that's a good solution for dust control. Otherwise, typical or standard vacuum dust extraction is also acceptable. Drilling FRP. When drilling FRP, tungsten carbide drill bits are recommended. I will add here, and now it's not recommended to cut FRP or drill FRP by either punching or shearing. That may lead to some damage with the glass fibers of the product, which could lead to reduced strength. So typically the recommended cutting method is using a cutting implement rather than a shear, and the recommended drilling method is using a drill as opposed to a punch or punching the product. High-speed steel drill bits can be used, but they'll get blunt very quickly. Once again, a bit like the timber blade for the circular saw. Tungsten carbide bits will hold their edge much better than traditional drill bits or than high-speed steel drill bits. And as I said, we get special tungsten tip drill bits made, which we're happy to supply. We make available for purchase for your project. I'd suggest giving them a try if you're doing a lot of cutting or drilling. But definitely, we typically get good feedback from the use of those. And lastly, just in relation to drill speed, treat FRP similarly to a hardwood. So use drill speeds appropriate to that. Once again, I'm sure as you try a bit of cutting and drilling, you'll soon find the most appropriate speeds, but treat the product similarly to hardwood as far as drill speeds. Now on to connections. We don't get the, shall I say, the luxury of welding FRP. It's designed to be thermally stable, which means it it's not able to undergo a plastic welding process or something like that. So as a result, bolted connections are typically used to connect FRP products, whether that be FRP structural sections, holding down FRP grating, connecting FRP handrail together, and so on. These connections would typically use standard bolts or set screws, nylock or other lock nuts, and flat washers. Traditionally or generally, the fixings would be 316 stainless as a minimum. Galvanized steel, galvanized fixing can be used if there's dissimilar metals concerns with the support structure. There's obviously no dissimilar metals or electrolysis issues with any fixing through FRP. And more exotic products like duplex or super duplex stainless 2205, 2506 can also be used. One comment on that is typically the exotic stainless become cost prohibitive. Lastly, FRP fixings are available, threaded rod, nuts, bolts, etc. The limitation with an FRP fixing is typically to achieve the same connection strength or fixing strength. There'd be an upsize in the size of the fixing. So, and this is a rule. This is just for way of comparison. What I'm about to say, not at all a rule of thumb. But theoretically, if you had, say, an M16 stainless bolt, you may need to go to an M20, M22 FRP fixing, something like that. That can become a real estate issue. There's not always enough physical space in the connection to make that possible whilst achieving the required edge distances for the connection and so on. Second to lastly, on connections, thread lockers can be used in areas where vibrations are concerned. I didn't write this down in the presentation, but it probably goes without saying if you're using stainless steel fixings, you should use a good anti-seize compound to prevent binding or galling. And lastly, just one more thing to note with FRP connections, recommended to use a flat washer on both sides of the bolted connection. So under the head of the bolt and also underneath the nut. So a flat washer on both sides of that connection rather than one side only, which is sometimes done with steel or metallic connections. A bit more on connections, this time in relation to square hollow sections or rectangular hollow sections. Where a fixing passes through a hollow section, anti-crush tubes are recommended to provide resistance against the deformation of that section due to bolt tightening. That also gives us our optimal load-bearing strength. So this is a little bit of a diagram showing how this works. Our bolt passes all the way through this section. We have flat washers on both sides, and then we have a sleeve that passes through the product. So that's the way this connection works. That sleeve can be inserted from one side. It doesn't have to be put up the end of the tube, of the end of the square tube, which is obviously quite difficult. If it's a long section, it can be put in from one side, and then another flat washer and a nut on the other side. We can see an example here on the right-hand side. We can see our square hollow section bearers, so two square hollow sections there connecting to this equal angle, and we can see that we have an anti-crush insert through there to allow a tighten to snug tight connection. The other option is if your not wanting to use anti-crush inserts, we can do a torque spec. This is typically torque recommendations in Newton meters, M6, M8, M10, M12, and M16 fixings. There's also a note here as far as oversized washers, assuming over the outside or overall diameter of the washer is 2.5 times the nominal size of the bolt and the thickness is 4 mil. If you're not wanting to do anti-crush, then a torque spec is required or recommended. In my experience on site would suggest that is a lot slower than putting in an anti-crush insert and just simply doing tighten to snug. But happy to have that discussion on your project. But just to note that either a crush block or a crush sleeve should be used, anti-crush sleeve, or otherwise we'd need to look at the torque spec for that product. Next, we're having a look at resealing FRP. And this is a common question we also get. I'd say in a lot of cases it's not done. There's a few good reasons to reseal your FRP. So after you've cut or drilled the product, it's suggested that a coating or a treatment's applied, typically brushed on site, if you're doing it on site. And anything we cut or drill for you in our factory will be resealed before we dispatch it, so you won't need to worry about it. All cut edges should have this applied, and it's best practice to put it in around drilled holes as well. Why do I need to crush it? Why do I need to apply this brush-on treatment or resin sealant treatment? 3 reasons. 1, it'll give us the best longevity of the product, and we'll look at the reason for that in a minute. Secondly, it helps protect the product against corrosion due to chemicals. So cut end doesn't have the same resin-rich surface that a factory edge, so manufactured outside of a C channel or something like that has. So we need to reapply or reinstate that protection to ensure that the product's not being corroded due to chemicals and moisture ingress into the product won't happen. FRP behaves a bit like the end grain of a timber in the sense that if you cut timber on the end grain and it's wet, moisture can track along the timber, along that material, and the product will swell. FRP can do something a bit like that and deteriorate structurally. Obviously, we don't want that. We want to get the best possible life out of it. And the last reason provides the best appearance for the finished product. All our products here at Treadwell have a colour pigment added to them. So there's not a colour via paint on the surface. The product has the colour pigment into it. If you cut it and observe, you'll notice that the cut edge is lighter in colour than the factory edge of the product. Once this resealing treatment is applied, that colour will be darkened and returned to the original colour of the product. So the third aspect is a nice to have, gives you the best possible appearance of the finished product. We supply a sealer kit, which is a 2-part resin and catalyst treatment to be brushed on. We're happy to provide that to you, and we're happy to also assist you with tracking something like that down if you're on site and need it quickly. So in summary, whenever the surface is altered, as in has been cut, drilled, sanded, or otherwise broken, the surface should be resealed to maintain the optimum performance. Treadwell supplies our X series sealer kits for that purpose, and obviously it's important that the product is mixed and applied correctly. Instructions are available on request to do that. Nearly finished, so we're running a little over time. I'll try and be quick. Handling FRP. A few things to think about. FRP is lighter in weight than traditional metallic products. It's non-conductive, so that helps us with 2 safety concerns around conductivity and weight, injuries due to weight. When you're cutting the product, dust will be generated. And obviously any sort of dust is a health hazard. So it would be recommended that PPE such as eye protection, ear protection, and breathing protection should be used. What that would typically look like is safety glasses, earplugs or earmuffs, and a P2 respirator. For best dust control, wet cutting is preferable, as we mentioned before. It's the best way to control the dust. However, please make sure, obviously, that your cutting equipment is suitable for wet cutting to prevent the risk of injury due to electric shock or something like that. And as we mentioned earlier, the lower product weight reduces the risk of injury caused by lifting or handling the product and injury due to that. Getting towards the end, on our website under the resources section, you can find this structural fabrication and repair guide. This is a document we've developed as a guide for our clients who are fabricating or installing our product. You'll see some of the things we discussed in this presentation and a lot more as well. So feel free to hop on the website and download that under the resources tab. It's a good read. It's a good document to have on hand, and gives you some details around what we've discussed today, but many more things as well around repair of the product and that sort of thing. And lastly, for things specific systems like FRP handrail, we also have product-specific guides for the assembly of the FRP handrail and so on. And you can find that on the website as well under the resources section, or feel free to reach out and discuss. And as usual, always happy to have project-specific discussions, always willing to come on site and have a look at your project and have a chat. Feel free to reach out, hello@treadwellgroup.com.au, or give us a call, 1-800-246-800 here in Australia and 0800-244-600 in New Zealand. We'll stay online now. I have got another meeting in a few minutes. We'll stay online for a couple of minutes and see if we can answer any questions that come up. Got a few questions come in. Bill, question, is the dust any more hazardous than plastic cutting? FRP dust is not a hazardous dust like something like asbestos. But obviously breathing in any dust is a health hazard, and you would want to take precautions to prevent that. But as far as the question, is the dust itself specifically a hazardous dust? No, it's not. But once again, it's a fairly light dust. It's quite a fine dust. It will remain in the air for a little while rather than sink immediately. So there is a possibility of breathing it in, and would recommend obviously taking suitable precautions to prevent that. Wet cutting is a good option. Sometimes that's not viable, and in those instances, vacuum dust extraction and PPE would be needed. Hope that helps. Just looks like someone just put their hand up. Just to clarify, if you'd like to ask a question, give the Q&A button a click and you'll get a tab. You can type us a question and we'll answer it here verbally. Question in regards to the fixing the FRP kick plate around a penetration with no handrail. So I'm assuming that we've got, say, a pipe penetration or something like that in the middle of a walkway or a structure. In that instance, we can apply in the factory an FRP kick plate to that edge. It's mechanically and chemically fixed, that is glued and screwed with an FRP flat plate to the edge of the grating. If that needs to be done on site, we can put together a kit for you with the FRP flat plate or a moulded circle, depending on the moulded circular piece of FRP, depending on the radius of your penetration. And that would be glued and screwed to the product. I'm not sure if I've got the gist. If that's not what you're thinking, please drop us some clarification on the chat. No worries, Anthony. Thanks for joining. Hope it was worthwhile. And I should say to anyone still online, if there's any questions or any topics you'd like covered in a future webinar, please drop it into the chat or flick us an email, hello@treadwellgroup.com.au, and we'd be happy to look to include those. And any feedback, good, bad, or ugly, waste of time, sorry, and please let us know. If it was worthwhile, please let us know. And once again, any topics you'd like to see, please let us know. That seems to be about the end of the questions. Sorry, I do have another meeting to go to, so can't stay on for much longer, but appreciate everyone joining. See you again in 2 weeks. And if you have any questions after this or a site-specific discussion, hello@treadwellgroup.com.au is the best email address to get hold of us, and myself or one of the team would be very happy to answer that query for you. Thanks again for joining, and have a good rest of the day. Cheers.